Example 3. Find the point on the parabola y squared is equal to 2x that is closest to the point 1, 4. So if we draw the parabola, here's our parabola y squared equals 2x. We have the point 1, 4, and we want to find the point that is closest to 1, 4. We can call this point xy. So the first thing we need to do is we need to find the distance. So we need to find the distance between the following 2 points. So we got to find a distance between 1, 4 and x, y. Okay, so recall that we're using our distance formula, and the distance formula tells us that we're going to take the value of x, and then we're going to subtract the x coordinate of 1, 4, and then square that, and then plus we're going to take the y coordinate of xy and subtract the y coordinate of 1, 4, and then we're going to square that. Okay, but what we know that xy is on the parabola. And if that is the case, if we take a look at the equation y squared equals 2x, so y squared equals 2x, okay, and we want to do is we want to solve for x. So let's solve for x so that we can get one variable under the square root. So we're going to take 2x, set that equal to y squared, and so now if we divide both sides by 2, we get x squared, x is equal to y squared divided by 2. And now what we're going to do is we're going to plug this x into the distance formula. So d is going to equal the following. So we're going to replace x now here to be the y squared over 2. So we have y squared over 2 minus 1 squared plus y minus 4 squared. And so therefore what that represents is now one variable underneath our radical sign. Okay, so now let's go ahead and square both sides. So if we square both sides, then we can say that d squared is going to equal y squared over 2 minus 1 squared plus y minus 4 squared. So what we're going to do now is we're going to call this function. So this is going to represent a function, and this function is going to be f of y. So f of y is going to equal d squared, which is equal to y squared over 2 minus 1 squared plus y minus 4 squared. Okay, so now what we want to do is now we want to be able to find the derivative of this function. So we want to find f prime of y. Okay, so if we take a look at the first term here, we're going to get 2 and multiply that by y squared over 2 minus 1. So that's going to be 2 times y squared over 2 minus 1. And then we got to multiply it by the derivative of what we get inside. Well, the derivative is going to be 2 over 2y, which is just y. So we have times y. Plus, if we take the derivative of y minus 4 to the second power, well, that's going to be 2 times y minus 4. And the derivative of y, or y minus 4, is going to give us 1. Okay, now let's go ahead and distribute and multiply this. Okay, so we're going to get f prime of y. Okay, if we distribute a 2 in the y, well, the 2 over 2 is going to leave us with y squared. Y times y squared is y cubed. And it's going to be 2 times minus y and y times that, so it's minus 2y. Okay, and then over here, we're going to distribute the 2, and 2 times 1 is 2, so we're going to get 2y minus 8. So now we can simplify this a little further by eliminating the 2 y's because those are opposites. So the derivative of this function is going to equal y cubed minus 8. Okay, so knowing what our definition states, and let's go back to that definition. And the definition that I'm referring to is the fact of the first derivative test for absolute value extreme values, And again, suppose that c is a critical number of a continuous function f defined on an interval. Well, the first thing we want to do is we're going to set f prime of y equal to 0, so we can find that critical number. So we have y cubed minus y, which is equal to 0. Y cubed is equal to 8. And if we take the cube root of both sides, then we know that y is going to equal 2. So looking at our definition up here, what this tells us is that f prime of y is going to be less than 0 when the value of y is less than 2, and we know that f prime of y is greater than 0 when y is greater than 2. So what does this tell us? Well, by the first derivative test, this tells us for the absolute extreme values up here that the absolute minimum occurs when y is equal to 2. However, what we can do is, since we know the minimum is at 2, okay, we're going to plug that in to find the value of x. So if we know that y is equal to 2, okay, we know that our ordered pair so far has a y value of 2. And then recall that if we let y is equal to 2, we're going to plug it into our function, which was x, which is equal to y squared over 2 to solve for x. And so therefore that becomes 2 squared over 2. And 4 over 2 is 2. So that means the value is 2, 2. And so we can say that the point on the parabola y squared, which is equal to 2x, closest to 1, 4 is the ordered pair to 2. So that means you come up here, this value we represented as 2, 2.